All right, looks like we're live. All right. Hello. How are you doing on this windy, rainy day? Hopefully you all have power. I'm happy I got power back on. Hoping it lasts for the full use of this live stream. What I wanted to do today was go over the two sections that we're reviewing for this rather short unit, section 11.4 and 11.5. I feel that I don't like putting it in other units because it makes them a little too long, and I like to really focus on this kind of understanding or ability to interpret what a graph looks like based on really understanding the function itself. So in section 11.4, we had the situation where you were going through and you were using Desmos graphs to kind of play around with manipulating functions. And you manipulated the parent function. You would add or subtract values to the x, and then you would add or subtract values to the whole x squared value, and then you would see what would happen. Hopefully you noticed that when you add or subtract values to x, you control what's called the horizontal shift. And the horizontal shift moves the graph left or right. Whenever you add or subtract values to the whole squared quantity, you control the vertical shift. And the vertical shift controls how far up or down you move the parabola. So by just looking at this function, I know that I've taken the standard parabola, the parent function, and I've moved it over 2 units to the right. Okay, so let me change colors here. I've moved it 2 units over to the right. So maybe like right here. That's 2 units over. And then I also know that I've moved it 3 units down. So maybe something like right here. Let's say that's 3 units down. So this is my official parabola. This is my final graph. I know by just looking at this and knowing how I've moved things left or right or up and down what my vertex is. In this exit ticket, this is problem 1 from exit ticket 11.4, you were asked to decide what in fact was the vertex of your parabola. Well, the vertex here was 2, -3, because we moved the graph 2 units to the right and 3 units down. Now, some people might have said, wait a minute, why was it if we are subtracting 2, we're moving it to the right, which is the positive direction? That didn't really make sense. Well, keep in mind, what I would say to students like this is I would just say plug in values and see what happens, right? Anytime you're subtracting values from x, you move it to the right. Anytime you're adding values, you move it to the left. So really quick, if we had changed around this to say x plus 2 squared minus 3, then the vertex would have been -2 and -3. The reason it would be -2 was because we ask ourselves, what value are we subtracting? Well, we would have been subtracting a -2 in this case. So here we're subtracting a +2. Here we would have been subtracting a -2. So hopefully that helps kind of clarify this idea of moving left or right and moving either in the positive direction or the negative. Now, using that idea, we can go ahead and take a look right here. Ahmed, did that example make sense? If it was x plus 2, we move to the left? I know there's a little bit of a 30-second delay for me seeing these, so did that help clarify it? All right, awesome. Yeah, that 30-second delay is actually, I think it's sometimes more like a 45-second delay. Going ahead and taking a look at this example, I'm going to rewrite the second function to be f of x equaling x minus -7 squared minus 4. Okay? These are the exact same thing, right? The double negatives is the same thing as a positive. So what I know here is the vertex is going to be -7, comma, negative 4. We moved over 7 units in the negative direction. So we moved 7 units to the left, and we moved 4 units down. I'm going to try to, let me see if I can get that graph. One thing you should know is I am terrible at drawing graphs, especially of parabolas. So, all right, whatever, something like that. Centered at 0, 0. And what we did was, we're going to say move it over 7 units in the negative direction. So that would be 1, 2, 3, 4, 5, 6, 7. So we moved it over 7 units this way. And then we have to move it down 4 units. 1, 2, 3, 4. So we took this parabola and we moved it over here. And that's where the vertex is, so this is where the new parabola, that's where it's located. And that's what it would look like. Hopefully this is making sense to you, this idea of, are you moving in the negative direction or are you moving in the positive direction? Keep practicing. If it's still a confusion to you, I would always recommend changing your function, so that way if you have a plus sign, you turn it into a negative sign. Okay? But those were the 2 problems from the exit tickets for 11.4. Let's take a look at 11.5. In 11.5, we talk about how to convert from a standard form quadratic to a vertex form. Okay? And why do we do that? Well, the vertex form, which, by the way, let me define that. That's f of x equaling x minus h squared plus k. That was the form we just worked with. This tells us what the vertex is. And, you know what I forgot? I should also put in an a here. A times x minus h squared plus k. So this tells us the vertex. And the a here, that tells us the scale factor. All that the a does is it controls how wide or how narrow the parabola is. Okay? So the benefit of having things in vertex form is you actually get a really accurate picture of what the graph is going to look like. If I just had things in standard form, off the top of my head, I don't know what this parabola would look like. I don't know where it's centered at. I don't know what the axis of symmetry is. I don't know what the vertex is. I don't know if it's wider or narrower. So one of the things that we can do is turn this into vertex form. Now, there's a couple ways of doing it. I'm going to try it both ways here. And you decide which method you like. Really, the only way to turn things from standard form into vertex form is to complete the square. So if I'm going to complete the square, I like to work with the f of x symbol. And what I would do first is I would add the constant number over. So I have this f of x plus 12 equaling x squared minus 4x. Then I have to take that middle term, negative 4, divide it by 2 and square that. Well, negative 4 divided by 2 is negative 2, and if I square that, I get a 4. That's the value that I'm going to add to both sides. Now, people are always trying to get a hold of me. All right, so I'm going to add 4 to both sides here. And let's see what we get. F of x is equal to 12 plus 4 is a 16. And then over here, there are no like terms, so I have x squared minus 4x plus 4. If you remember, the reason we would complete the square was to force the polynomial to be able to be factored down. So we can factor the right-hand side here. We would have f of x is, f of x plus 16 is equal to x minus 2 squared. We can then move the 16 back over and get f of x is equal to x minus 2 squared minus 16. This function right here is the exact same thing as our original function. Nothing different other than the form. You can check this. All you would have to do is remultiply x minus 2 times x minus 2 and then subtract 16. You would get the exact same function back, okay? Now, that's one way of completing the square. What I'd like to do now is show you how to complete the square where you keep the value of negative 12 on the same side. Some students have the book and they were kind of looking over this and they're getting a little confused. You can complete the square without having to move the 12 over. I like personally moving the 12 over just because that's what we would do before, but you can do it without having to do that. I'm going to show you an example of that. We're going to rework this problem and try to see kind of how I'm doing that here. I have f of x equaling x squared minus 4x and a minus 12. What I'm going to do now, instead of moving the 12 over, I'm just going to leave it. Some books will say, try to write this where you include a space in between the 4x and the negative 12. What you're then going to do is, just like before, take the middle term, divide it by 2, and square it. Well, we had said that was already going to be a positive 4. So we're going to add 4 to this side. But the trouble is if you add 4 to this side, that would totally change around the function, wouldn't it? You should also add 4 to this side. But we said before, we're not really working with this side of the function. So what can we do if we add 4 to the right-hand side? That would totally change the function, right? You do to one side, you got to do the other side. So if I added 4 to one side, that would totally give me a brand new function. I can't just say add 4, right? What else could I do to this side so that way adding 4 to the right-hand side doesn't change it around? Well, what students were recognizing from the book is if you add 4 to this side, you could also subtract 4 from this side. Let's see how this works out. F of x is equal to x squared minus 4x, and then we said add 4 and subtract 4 from both sides. If I combine like terms right now, those 4's are just going to cancel out, right? So some of you might be saying, well, what's the big deal with this? You added 4 and you subtracted it, that would just cancel out and make a 0. What we would say is put parentheses in here in very careful ways. Where I've added the 4, put parentheses around it. And then have the negative 4 and the negative 12 on the outside. You'll notice this can be factored down just like before. We would get an x minus 2 squared, and the negative 4 and the negative 12 make negative 16. This is another way of completing the square, except this time you don't work with the left-hand side. This time all that you do is everything on the right-hand side, and the big idea here is whatever you add to the one side, you also subtract it from the same side. Okay? This process of adding the same thing to both sides, or adding to one side and subtracting from the same side, that's the same thing as the additive property of equality. The additive property said you could add the same number to both sides, and you would still have an equal sign. Well, you could also add and subtract the same number from both sides, and it would still stay equal. And you can verify this, that this works. You can go ahead and remultiply things through and subtract the 16, and you get it to work. Now, I don't care which method you do. I don't care if you complete the square this way or this way. You'll notice in videos, I a lot of times like to do this method on the left. That's just for me. Sometimes on answer keys, I'll do the method on the right because that's sometimes what the book does. It doesn't matter. As long as you're comfortable with each of the steps and you can see how it's done, you can use either technique. So, what did we do here? Well, all that we did was we rewrote this particular function. So let me go ahead and clear some space here, and let's work with this function, and let's see what information it tells us. So we said in vertex form, the function is x minus 2 squared minus 16. Now, we want to be able to look at this function and interpret what the graph would look like. Well, we know right away that the vertex is going to be 2, negative 16. It tells us right here. There's the vertex, the x point and the y point. So we moved this function over. So if we had the parabola, it was moved 2 units over and then like 16 units down. Okay, so it's way down in the 4th quadrant. We also know that the scale factor here was a 1. That little number in front of the parentheses is a 1 here. There's like an imaginary 1. So that means that the width, the thickness or the thinness of the graph has not changed. It's the same as the parent function. You didn't increase it. Like you didn't make it more narrow or you didn't make it wider. Okay? So if I'm thinking about this graph, I'm thinking, okay, it's about the same width or the same thickness as the parent function. I know where its vertex is. By the way, this number in front is a positive, right? You don't see any negative signs out front of the parentheses. That means that this vertex, this parabola, upwards facing. This parabola opens upwards. If there was a negative sign out front, if it was negative x minus 2 squared minus 16, it would open downwards, okay? This number, whatever it is out front, positive or negative, controls does the parabola open upwards or downwards. It also controls how wide or how thick it is. So right away we know we have a parabola that's open upwards, and we know where its vertex is. This kind of helps us start to draw the graph out. Now, one other thing that we have to think about. Let's say I started creating this graph here. And I knew where to place the vertex. And let's see here. So it's down 16 units and over 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and over 1, 2. I have just enough space here. If my stylus would work. Oh, come on. Why isn't it working? The one spot I want to color. No, it's supposed to be right. Whatever. Anyways, we know yeah, right there. Finally lets me color there. That's where the vertex is. And I know that the thickness is going to be the same as the parent function. If you study the parent function, one of the things you'll notice is that if you go over 1 point and up 1 point, you also cross these spots. The parent function, as you go over 1 unit, you go up 1 unit. As you go over 2 units, you go up 4 units. Basically, you just recreate the parent function. I told you I'm terrible at drawing these. So, we could try to draw that graph. And, of course, now my screen mirroring stops. We could try to draw that graph. Give me 1 second here. All right, there we go. Oh my gosh, today is like the worst for technology issues. What was I saying? Okay, we could draw this graph and we could leave it like that. Okay. Let's see if this is going to work here. All right, fingers crossed this stays working. Okay. Like I said, we could try to draw this graph and leave it as is. But it's helpful for us to notice, okay, this is the general shape of the graph, but what happens over time when I get to the x-axis? Where do I cross the x-axis? That might actually help be quite a bit, that helps with a lot of information. If you read about the application problems, from this section, you'll notice that we tend to want to know, where do we cross the x-axis? That question is something that we can answer right away, because you should know how to find that. When do we cross the x-axis? When do we have x-intercepts? Well, remember, when we need to find the intercepts, we're asking ourselves, what is x when y is equal to 0? Any point on the x-axis has some x point, and its y point is 0. So, all that we need to say to ourselves to find the x-intercepts is basically, when does the function equal 0? We've already done this. We did this last unit. We already learned, how do you figure out when a quadratic equation is equal to 0? So, couple ways of doing this. You could say x squared minus 4x minus 12 equaling 0. You could solve this by the quadratic formula. You could try maybe factoring this and seeing if that works with the zero product property. Or you could use completing the square, which you already did, and setting that equal to 0, and then just solving from there. Lots of different ways you can go about doing this. That's kind of why I really like asking students, how do you find the x-intercepts? Well, it's just when the function is equal to 0, and you already know how to do that. So pick which method you like. Most students really like the quadratic formula, but a lot of times students are like, if I already completed the square, might as well just keep going with that, right? I could add 16 to both sides. I could take the square root of both sides. I would get plus or minus 4. And then I could add 2 to that. So 2 plus or minus 4. Let's see. 2 plus 4 is 6. And 2 minus 4 is negative 2. So that means I would cross the x-axis at negative 2 and positive 6. 1, 2, 3, 4, 5, 6. All right. I know that my parabola will cross at these values. It will also have a vertex down here. So here's the axis of symmetry. Again, apologize. I apologize for the very poor drawing skills. But we have the axis of symmetry. We know where the vertex is, and we can easily figure out what the x-intercepts are. So this tells us it gives us a very good picture of what the graph is. Now, a lot of people might be saying, okay, big deal. We have calculators. We could plug this stuff in. We could just plug in values for x and start seeing what we get. Yes, that's true, but a lot of times and you mostly will notice this when you get into like physics classes, you want to be able to interpret what the graph looks like. One, because you might be dealing with x in the thousands of units or whatever, and y in the thousands of units. So it helps you kind of pick certain values, and you really want to be able to get an interpretation, understanding of the graph for when you get into calculus. Okay? So what are some key components that we should know about this? The vertex, the x-intercepts, and is it opening upwards or downwards? Let's try some more problems, and we'll try to keep this work a little more neat. Now, take a look at this one. This is problem 4 from the independent practice for today. We have f of x equaling 2x squared plus 6x minus 8. So we need to figure out, and I'll write this to the side, what the vertex is. We need to figure out the x-intercepts. And we need to figure out, I'm going to use the vocab word concavity. Concavity just means, are you open upwards or downwards? Okay. I'll just keep those to the side there, and we'll try to fill them in as we go along. So really, with these problems, it's up to you to decide where you want to start. So, I don't know, any opinions from the people watching this video? Let me know in the live chat if you want to start in any particular way. We could convert this to vertex form and figure out what the vertex is right away. Or do you want to figure out what the x-intercepts are right away? It doesn't matter. You could answer either of these questions first. Your call. Any preference from anyone in the live chat? Additionally, if you convert it to vertex form, you would know what the vertex is. Keep in mind, though, we also have the vertex formula that we could use. So I might solve this a couple different ways. I'm not really seeing anyone have any particular preference in the live chat, so maybe let's start with the vertex. Maybe I'll start putting it into vertex formula. Does that sound okay? Let's give it a try. So to put things into the vertex form, I'm going to have to complete the square. But the trouble is, when you are going to complete the square, you are dealing with a 2 out front here. Vertex first, you got it. Okay, so we got the 2 out front, and that's not allowed when we complete the square. It has to be a 1. But we said there's an easy fix for that. You could just divide both sides by 2. Okay, so let's see what we would get here. F of x divided by 2 equals x squared plus 3x minus 4. I'm going to do the technique where I work with both sides when I complete the square. That's just my preferred method. I hope that's okay. Otherwise, you can basically, well, we'll talk about that in a little bit if anyone has questions. So I divided both sides by 2. Now I can complete the square. What I'm going to do is I'm going to add 4 to both sides. So I get f of x divided by 2 plus 4 equals x squared plus 3x. I have to take 3, divide it by 2, and then square that. Okay, well, obviously this isn't going to give us a whole number, and that's okay. Don't always expect it to. Let me grab my calculator real quick. Now, when we square everything, we're going to get a 9 over 4. So that's what I have to add to both sides, 9/4. So when we add that to both sides, we have f of x over 2 plus, what's 4 plus 9/4? Well, 4 over 4, so that's 16 over 4. And 16 and 9, is that 25/4? Let me check here my calculator. Hey, 25 over 4. I like when mental math works out. And that equals x squared plus 3x plus 9/4. Okay, this should be able to be factored down. It actually has to be able to be factored down. So f of x over 2 plus 25 over 4 is equal to x plus 3/2 squared. Remember, this is just whatever the middle term divided by 2 was. So that's how I get the factors. Please let me know if you have any questions about how I just got to there, okay? And then I can subtract 25/4 from both sides. And we'll end up with f of x over 2 is equaling x plus 3/2 squared minus 25 over 4. Now, a couple things to note here. I have to remultiply everything by 2 because I've gone and I've completed the square for this function. What I needed to do was complete the square for that function, the thing that had the 2 in it. So before I finish my work here, I have to multiply everything by 2. So what I will really get, just so I can save some space here, f of x is equal to 2 times x plus 3/2 squared minus 25 over 2. Okay? What I've done here is I've just distributed the 2 to both sides. I multiplied it to the parentheses, and I multiplied it to the outside number. This is the simplified form of the vertex form of the function. Okay? This is the exact same thing as the original function. Take a minute, look over the work. Let me know if you have any questions. I'm going to want to erase this to get us some extra space, but we know what the vertex is. Let me go ahead and write that vertex in. Now, these I wrote as fractions. It's probably more helpful to us if we write them as like decimals or mixed numbers, because think about if you're trying to graph, you want to go down 25 over 2 units. That's not always that helpful. So 25 over 2 units is the same thing as 12.5, and 3 over 2 is the same thing as 1.5. So the vertex should be negative 1.5 units and negative 12.5 units. I just wrote them as decimals. You can leave them as mixed numbers, whatever. It's just that's much easier to graph that point. I got to go over 1.5 units to the left and down 12.5 units. Not seeing anyone with questions on this, so what I'm going to do is I'm going to erase this work. Again, don't worry, this video is being recorded and I post it right afterwards, so you can go back and take a look at it. So I'm going to erase this work for now, and then I'll rewrite what the function is up top. And then we'll answer the next question of how to find the x-intercepts. And what I'd like to do is actually take a quick minute at the end of this just to go over another method where you didn't have to put it in vertex form. But we'll talk about that in just a sec. So we got f of x equaling 2 times x plus 3/2 squared minus 25 over 2. All right, now we have to figure out what the x-intercepts are. So a couple ways you could do that. Basically, you just have to figure out when does f of x equal 0. Okay, when is the output 0? That tells you what the x-intercepts are. So you have options. You can say, all right, I'm going to solve this by trying to factor it and doing the zero product property. I might even do the quadratic formula for this, or I could say, well, I've already completed the square, so I could try solving it by completing the square. Any preference? Anyone watching? I'm good to do any method you guys want. A lot of times students like to complete the square. A lot of times, though, students are like, we've already put it in vertex formula. Might as well solve that. I will say this one, I'm pretty sure this one can be factored. Yeah. If I'm thinking off the top of my head, yeah, we could factor and use the zero product property. So we have all possible options. Any preference? And I would say, you'll notice on the answer key, I actually do multiple techniques. Sometimes I factor it, sometimes I use quadratic formula, sometimes I just solve once I've completed the square. I do that to show you there's a variety of techniques, okay? And it's good to be well-versed in all of the different formats. And again, nothing new, stuff that we've done before, so any preference? I'm not really seeing anything in the live chat, so I guess I could just pick a method. Well, we did it by completing the square last time, so no preference. All right, maybe let me try factoring it this time, just because this one will factor. Actually, you know what? Yeah, let's go ahead. Let's just give it a try. Since we did complete the square last time, let's go ahead and factor this thing down. Will that always work? No, but I wrote this problem, so I made it nice for us. One of the things I'll do first is divide the GCF of 2 out. Okay, and we're left with an x squared. That's an x squared plus 3x minus 4 equaling 0. That's the thing that we have to factor down. So let's say that's x and an x. So we have two binomials. What multiplies to give us negative 4, but adds to give us 3? That should be a positive 4 and a negative 1. So the roots for, or the x-intercepts here are going to be x equals negative 4 and x equals positive 1. Because remember, we set each of these equal to 0 and solve for x. So we know what the x-intercepts are. Let me go ahead and write those down. You could write them like this, or it's sometimes more helpful to write it as actual coordinate point. Negative 4 and 0. That's a terrible 0. Negative 4 and 0. And 1 and 0. So now I know where we cross the x-axis. You could have also done the quadratic formula for this. You could have done x equals negative 6 plus or minus the square root of 6 squared minus 4 times 2 times negative 8 all over 2 times 2. You would have gotten the same answer. When you fully simplify, you would have gotten a negative 4 and a positive 1. So, your call, whatever you want to do. So, we have the x-intercepts. We have the vertex. So, we have a pretty good picture of what the graph is going to look like. We also know, is this graph opening upwards or is it opening downwards? We'll take a minute and try to think to yourself, the vertex of negative 1.5 and negative 12.5, that's somewhere down here, right? And if I'm crossing at negative 4, 0 and 1, 0, that means I must be opening upwards, right? Just knowing the vertex and the x-intercepts, you can pretty much tell, is your parabola opening upwards or is it opening downwards? But what's another way of telling? I'm going to ask my listeners this question. I know there's a little bit of a delay. We can obviously tell from the vertex and the x-intercepts, are we opening upwards or downwards? That's called the concavity. Are you opening up or down? What is another way, by just looking at the function, that we know if we're opening upwards or downwards? That's my question to you. I know there's a little bit of a delay, but try to type in, what do you think is another way of determining are we opening upwards or downwards by just looking at either of these functions? I feel like I should have Jeopardy music in the background. Actually, YouTube would probably pull the video then because I don't own the Jeopardy music rights. And while you're setting that up, I should probably clear some space here. So what is another way that we know that we are opening upwards? Our concavity is up. The parabolas, the ends are increasing forever and ever. They're not facing downwards and decreasing forever and ever. The sign on the first number, exactly, yes, this is a positive 2. That tells us we're opening upwards. If it was a negative 2, right? If it was negative 2, then we would go downwards. You don't have to have this in vertex form to know that. You can just look at this number as well. Notice that this number is the same as it is in vertex form. Okay? So by just looking at the number attached to the x squared or this lead number in vertex form, that tells you whether you're opening upwards or downwards. So we are opening upwards, and I'll say this, I'm not necessarily bothered too much with this. Normally, if we were meeting in class face-to-face, we would actually go a little more in detail to this. I'm planning on that for the 176 bridge class. But noticing that this is a 2 here not only tells us that we're opening upwards, but it also tells us that we are thinner than the parent function. If you took the parent function, we're actually thinner. We've narrowed the parabola down. One of the ways to notice this, when that leading term is a 2, that helps us determine what the next 2 coordinate points are from the vertex. So what I'd like to do really quick is try to sketch a little graph of this. So let me clear some space here, and let me try to sketch a graph. Let me see. How do I want to do this? Well, this should be okay. Of course, my stylus wants to quit on me. Here we go. That was almost a perfect straight line. All right, and now let's say here's the x-axis and the y-axis, or the f of x-axis. Now the vertex, we've moved it 1.5 units to the left. So let's say that's right there, right in the middle, and 12.5 units down. So let's say that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and a half. So maybe my stylus isn't that accurate, but I don't know, somewhere right in the center of that circle. That's where the vertex is, and we know where the x-intercepts are, 1, 0, and negative 4, 0, 1, 2, 3, 4. So we can, using these 3 points, try to sketch a little graph. One of the things I'd like you to notice is the axis of symmetry here is what I guess I'm going to say equidistant from each of the x-intercepts. The distance between each of these x-intercepts to the axis of symmetry is the same thing. It was basically 2.5 units away. So hopefully that should make sense to you. The x-intercepts are going to be equally spaced away from the vertex. And you could try your best at sketching a little graph here. Okay, that was terrible, but whatever. One of the things I'm going to say is when we had the parent function, so a little side graph here, when we had the parent function, we knew that its thickness, because the parent function x squared, the number out front was a 1. That tells us that when you go over 1 unit, you go up 1 unit. When you go over 1 unit, you go up 1 unit. That's for the first 2 coordinate points after the origin. The next 2, you had to go over 2 and then up 4, and over 2 and up 4. And that would tell you the thickness of the graph. Okay, so this number, the A, tells you the thickness or thinness of the graph, but it also tells you where to go for the next points. So for example, when it was a 1 here, I would go over 1 unit and up 1 unit. If I had a 2x squared, let me do that in a different color. Let me do that in green. 2x squared, that means go over 1 unit and up 2 units. Over 1 unit and up 2 units. That alters the graph. It makes it thinner. You can kind of think of this almost like slope. It's not really slope, but it affects the, I would say, the dimension of the graph, how thick or how thin it is. Okay? Again, we can get more into this later on in spring semester. But for right now, just know that being a positive 2, it's going to open upwards, and you can just connect these points as best you can. But what I'm going to do here is say, okay, since this is a 2, if I go over 1 unit, I can go up 1, 2 units. And this is where the next coordinate point would be. Go over 1 unit and up 2 units, and that's where the next coordinate point is. Having more points just helps you kind of sketch the graph out. Well, if you're okay at drawing, it does. If you're like me, there's no hope. All right, hey, that actually wasn't that bad. So I know that this is now going to be thinner than the parent function. So what we did, we moved the parent function around, we kept it facing upward, and we just made it a little thinner. Really, all that you need to know are these ideas. Where's the vertex? Where's the x-intercept? Okay. Let's go ahead and try a couple more problems. Again, we got to figure out what the vertex is. We need to know the x-intercepts, and we need to know the concavity. Is it opening upwards or downwards? All right. Let's go ahead, and I'm going to do this without using the vertex formula first. Okay? We could go ahead and just convert this into a vertex formula. If you like, go ahead and do that. I'm going to try a different technique. I'm going to use the vertex formula. If you watched the video today, I said there was really two ways of taking something from the standard form and figuring out what the vertex is. One is just converting it to vertex form right away. The other is doing the vertex formula. That was negative b over 2a. That tells us what the x value is. So let me try that. Negative 2 over 2 times 2. Let's see what that is. Negative 2 is positive 2, and 2 times 2 is 4. So that's a half. I know now for my vertex, the x value is going to be a half. So I have the first part of my vertex. It's a half. Now, remember, the vertex is a coordinate point. I have to figure out what the y value is. So to do that, all I have to do is plug this in. I know I have a function that models all of these x and y points. So if I say the vertex occurs when x is a half, well, just figure out what y is by plugging it in. 2 times a half squared minus 2 times a half plus 4. All right, a half squared is 1/4. 2 times a half is just 1. So let's see what we get here. 2 times 1/4 is 1/2. Negative 1 plus 4 is positive 3. So what's this, just 3.5? Okay. The vertex occurs at a half and negative 3/2. Same thing as 0.5 and 3.5. Did I say negative 3.5? I don't know why I said that. Sorry about that. But this is the way, an alternative way of finding the vertex. You could, if you want, if you're like, nah, I don't want to remember that. I prefer just putting it in vertex form. I'm fine with completing the square. I just want to go for it. That's fine. Go ahead and do that. But here's an alternative technique that we can use. Now, let's go ahead and find the x-intercepts. That's when f of x is equal to 0. So when is 2x squared minus 2x plus 4 equaling 0? Well, I could factor out a 2 from here. So really, all I have to do is figure out when does x squared minus x plus 2 equals 0. You know what I haven't done? I haven't done the quadratic formula yet. Why don't I give that one a try? X is equal to negative 1 plus or minus the square root of, let's see, that's negative 1 squared minus 4 times 1 times 2 all over 2 times 1. Oh, I probably should have gotten some more space here, but that's okay. That becomes a positive 1 plus or minus, well, let's see, square root of, let's see, negative 1 squared is a 1. And you know what? I'd like more space. So give me 1 sec. Let me just clear some space here. And let me see what we had. We were figuring out x squared minus x plus 2 equaling 0. And I said x equals negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times 2 all over 2 times 1. Okay. Negative 1 is a positive 1 plus or minus negative 1 squared is 1 minus 4 times 1 is 4 times 2 is 8 all over 2. All right, let's keep simplifying. We get 1 plus or minus the square root of negative 7 over 2. And if I'm simplifying, that's 1 plus or minus I root 7 over 2. Take a minute. What do you notice about this? Let's see if anyone can comment in the live chat. What do you notice that's unique about this answer? We have our vertex, and we went to solve for the x-intercepts, and what did we get? Well, I'll say we ended up with a complex number, right? I have 1 plus or minus I root 7 over 2. What does that mean about our graph? If the x-intercepts are complex numbers, what does that mean about our graph? Take a minute. Let's see if we can get someone to comment. We went to solve for the x-intercepts, and we have a complex number. A number that's not even a real number. It's purely complex. I don't know where I would be, because I doesn't exist on the real number line. What do we think? We went to solve for the x-intercepts, and we have a purely complex number. What could that mean about our graph? In fact, let me start trying to sketch. So while you're thinking, if you think you got an answer, go ahead and comment it in the live chat. Let me try to sketch a little graph of what we have here. Let's see. The vertex is over a half, so just over 1/2, and up 3/2, so 1, 2, 3 and a half. So, like in the somewhere in the center of this circle is the vertex. All right, right at that dot there. My brain cannot function on that level. That's okay. So let's skip the x-intercepts for right now. Let's hold off on that for a second. We'll come back to this. What is the concavity? We have the vertex. It's right there. What is the concavity of this graph? Is it opening upwards or is it opening downwards? We didn't turn it into vertex form, which is okay. We can still tell if it's opening upwards or downwards. Is it upwards or is it downwards? If you want to, you can put it into vertex form, but we don't have to. What do we think? What do we think? Your brain should be able to function on this level at least, because you answered it before. Are we opening up or are we down? We should be able to just look at the function. Yeah, we're opening upwards because that number is a positive. You could go ahead and put this into vertex form if you want. Your A value will still be a 2. That means we're going like this. And in fact, we're probably thinner than the parent function, but that's in the direction that we're going. Okay, we're concave up. We have our vertex right about there. What does it now mean that our x-intercepts are complex numbers? What does getting a complex number say about our x-intercepts? What do you think? We have this picture of a graph, and we know it's a parabola, right? It's going to keep increasing forever and ever and ever, right? It's never going to dip back down. So, what does having a purely complex number tell us about our x-intercepts. We went and we did the quadratic formula. We went to find our x-intercepts, but we got purely complex, I was about to say purely imaginary numbers. Something that isn't a real number. It's a complex number, but it's not real. So what does that tell us about our x-intercepts? In my head, I'm playing the Jeopardy music. They don't exist, maybe? That's correct. They don't exist. And we can tell that by just looking at the graph, right? Will this parabola ever cross the x-axis? No, it doesn't. So when you get a complex number, a purely complex number, or I should say sometimes an imaginary number, for your x value, that means your answer, your parabola, never crosses the x-axis, okay? The reason being, if you wanted to find when this function is equal to 0, you would have to be in what's called the complex plane. We'll talk about that in the spring semester. But really, this is telling you there's no real number that satisfies this. There is no real number that satisfies this, so you never cross the x-axis in the real number system. So that tells you that our graph is either above the axis or below the axis and never crossing it. So, good job with that. Let's try one more problem, and then I want to get into the exit ticket problems for today. Here we have yet another function that we have to figure out its vertex, and we should probably also figure out the x-intercepts and the concavity. Well, I don't know. Let's go ahead and put it into vertex form. Let's get some practice with that. So I'm going to take f of x equaling x squared minus 4x plus 6. I'm going to subtract 6 from both sides. I get f of x minus 6 is equal to x squared minus 4x. I'm going to take negative 4 divided by 2 and square that. That's negative 2 squared, which is just a 4. So let's add 4 to both sides. We get f of x minus 2 is equaling to x squared minus 4x plus 4. I'll get rid of this side work here. This should now be able to be factored down. So we have f of x minus 2 equaling x minus 2 squared. And then we can just add 2 to both sides, and we'll end with f of x equals x minus 2 squared plus 2. Now, we know what the vertex is, so let's go ahead and write that down. The vertex is going to be a positive 2 and a positive 2. So we know where we're at. This is in the first quadrant, so we know where we're centered at. That's our vertex. Now, we should go and figure out what the x-intercepts are. Well, I could do the quadratic equation, or I could just solve it using completing the square. Might as well just do that. I'll just say, let's set this function equaling to 0. I'll subtract 2 from both sides. I get x minus 2 squared equals negative 2. And when I take the square root, I get the square root of negative 2 equaling x minus 2. Wait a minute. As I'm doing this work, I have a negative root. So when I go to solve for the x-intercepts, I have x equals 2 plus or minus I root 2. That's a problem. I don't even need to get to this answer. I can just say right here, look, I have a negative root. That tells me right away that my x-intercepts aren't going to exist. They are not real. There are no real x-intercepts here, okay? The only solution to when the function is equal to 0 is a purely complex number. So no real number will work here. And you don't even need to necessarily be able to analyze that. Take a look. The concavity of the function, since this is like a 1 out front, there's no negative. It's opening upwards. So if I were to graph this, if we were to graph this and get a little picture of what's going on, we're centered at 2, 2, so that's like right here, and we're opening upwards. That means we never cross the axis. So you can tell the fact that we will not have any real intercepts because, well, you know the vertex and you know if it's opening upwards or not. You know which direction it is. You can also tell by when you go to solve the equation, whether you solve it using the completed square vertex form or whether you use the quadratic formula, you'll end up with a negative root. You'll end up with something that has to have the I value, the complex unit I. So that's a problem, right? That tells us that we will not have any real x values. I'm sorry, let me restate that. That tells us we will not have any real x-intercepts. So we will never cross the real x-axis. Now let's go ahead and get into the exit ticket problems because I want people to be able to check over their work. On the exit ticket, all I wanted you to do was just convert this from standard form into vertex form. So let's go ahead and give that a try. I'm going to add 2 to both sides. I get f of x plus 2 equals x squared plus 2x. 2 divided by 2 squared. Well, 2 divided by 2 is 1, and 1 squared is, well, that's just 1. So let me add 1 to both sides. We have f of x plus 3 is equal to x squared plus 2x plus 1. Well, that right-hand side, that can be factored down. So we have f of x plus 3 is equal to x plus 1 squared. And if I subtract 3 from both sides, I'll end up with f of x equals x plus 1 squared minus 3. There is the vertex form, okay? Easy as that. All you got to do is complete the square. Now, I did this where I left f of x, where I should say I worked with both sides. You could have done this also by doing f of x equaling x squared plus 2x minus 2, and you could have decided to, right here, start from this step where you add 1 and subtract 1 from both sides. So you would have ended up with x squared plus 2x plus 1 minus 1 minus 2, and you would have said, put the parentheses around these 3 values. That would have factored down to an x plus 1 squared, and this would have become a negative 3. Again, that's if you like that method. Not my preferred technique, but if you like it, go ahead. Nothing wrong with it. Let's go ahead and try the next problem. Notice here that we are dealing with a value that's not a 1 as the leading term. That's a problem, so I'm going to have to divide both sides by 3. We'll end up with f of x over 3 equals x squared minus 4x plus whatever 13 over 3 is. All right, well, I'm going to have to, let me see, I'm going to subtract 13 over 3 from both sides. So I have whatever f of x over 3 is minus 13 over 3 equaling x squared minus 4x. Those canceled. And then, well, we've done this before, negative 4 divided by 2 squared. That's just a positive 4. So I'm going to add 4 to both sides. All right, let's see. F of x over 3. And then, well, we have negative 13 over 3. And I'm adding positive 4 to that. That should be a negative 1/3. equaling x squared minus 4x plus 4. That's f of x over 3 minus 1/3 equals x minus 2 squared. That's what we get when we go ahead and factor this down. I can add the 1/3 to both sides and get f of x over 3 equals x minus 2 squared plus 1/3. And then if I multiply both sides by 3, I get f of x equals 3 times x minus 2 squared plus 1. Take a look at this work. Make sure it's making sense to you. Again, we're just completing the square here. I first have to divide both sides by 3, then I move the c term over. I got to add what half the b term squared is to both sides, factor it down, and then just resolve for f of x. Let me know if you have any questions or if there's anything more you'd like me to review. That was pretty much all that I had planned for today for our live chat, but if you have any questions, please let me know. You can let me know in the live chat here if there's anything else you'd like me to review or anything you'd like me to re-explain. Sometimes I have the tendency of talking and working through problems a bit too quickly. But that's basically all that I had to review. So you should be able to work through the homework and feel pretty comfortable with it. Again, it's really nothing new to us. Just be able to figure out what the vertex is, either by putting it in vertex form or using the formula, the negative b over 2a. And then the only other thing is figure out what the x-intercepts are. Well, you've already done that. That's what we did all of last unit. So, and then I guess the only other thing is having that vocab word of concavity. I put a little note on the class website. Don't really worry about concavity just yet. Just know that it means opening upwards or downwards. So if you were listening to this live stream or you watch it later, you can go ahead and do that work where you say what's up, what's down. But otherwise, just being able to identify vertex and x-intercepts are important. I'm not seeing any comments over in the live chat about things people would like me to review or problems they'd like me to go over. Wednesday, we are going to be starting a new unit. That's when the test is going to open. It's just a short quiz that I have for this particular section. Something super short, pretty quick. So Wednesday, let me know if you have any additional questions that you'd like me to review or things you'd like me to go over, either in our morning or afternoon live stream. Again, once I'm done with this, I'm going to post it up to the YouTube page, and I'll probably put it in one of our playlists so you can go back and see all of our work from this section. All right. Until next time, take care.